Over the couple of last years, let's say if we go back 20 years, there has been a big or huge influx of renewable energies into the grid. And we actually now can see what is projected as the peak of fossil fuels within this decade. Somewhere around 2030 will be where fossil fuel usage will be starting to go down in the world. Introducing then renewables is the key for this. And there is wind, offshore wind and onshore wind, and there are solar plants and so on. But there has also been a big change in how the grid works with respect to renewables. That when we are introducing renewables, it's not introducing big and huge power plants, it is introducing smaller distributed energy resources into the grid. So the grid needs to transform, and that's one of the big trends that we see, that we are moving from a, let's say, big production facility into where the power flows from the big production centers down into the grid, to a grid where you have both the big production centers and also local production with renewables. And this have transformed how the grid works, both in terms of power but also in terms of monetary flow that is now bi-directional. And this is something that the grid needs to handle. What we see is two different things at the same time here. When we look 15 years ahead or to 2050, we see that the growth of the energy consumption as a whole will not increase that much. The projection is only 14% increase from where we are today until 2050. And this is due to many different things, but there are a lot of, let's say, efficiency changes and also huge change of the energy mix as such. As we mentioned earlier, with the fossil fuel is being reduced, and that is to a large extent changing the mix towards electricity and hydrogen instead. So there is a very large change in the consumption mix, but it is not as big projected increase in the power consumption as such. This is interesting, that the renewables that are being introduced, it is in a rapid pace changing from this fossil fuel and bioenergy and whatever you have that has been the old production portion. Hydroelectric, water power plants and so on is not being introduced so much. I mean, what is available has been utilized in the world. However, wind and solar is coming to a large extent. And looking at, let's say, renewable projects over the next 15 years, we will see a doubling of the production of renewable energy. And the change of the mix is going that electricity is going to be increasing twice as much. So both the mix of renewable and electricity generation, energy generation, and also the usage of electricity as the conveyor of energy is changing. Yeah, I mean, we have built an electricity grid, and we have also a lot of other, let's say, energy transportation systems that are in working today. I mean, we have a very efficient way of transmitting oil and gas from producer to consumer in the world. And the grid has been built the same since the beginning of the end of since going back to the 1800s. The grid has been built on big power production centers into flowing down to the consumers in the transformation of the voltage and how the power is flowing. But when we now introduce these renewables, the grid has to be able to handle small small power production centers, and they are distributed, and they are very often out of control from the grid owner. It can be local productions, private persons that have their own solar plants. There are also energy storages introduced into the grid, and all of this needs to be controlled somehow, because we still need to have 50 hertz or 60 hertz in those countries, but we need to have the frequency under control, and we need to have power where we need it at that point in time. And all of this needs coordination. And in the old systems, this was always done with the big, huge power plants, often hydroelectric power plants that were controlling these minute changes. Today we need to handle this very, let's say, volatile production landscape. And this is done with communication between the power producer and the grid owner. As I mentioned, the power production has been centralized for a very long time, and as this is changing now into these local power production centers, and there has to be a balance between controlling the local centers and the local consumption, and this is totally new for the energy market, and is something that the energy companies have been battling now for a couple of years, and the change has been rapid. And I think that in some countries they have been early adopting and understanding this, and in other countries we are waking up and seeing that this change is happening now, and that gives a lot of challenge to the grid owner that are responsible for frequency and power balance. How do we handle a grid with more volatile sources that are less, you have less rotating masses, and you need to balance frequency control somehow in a distributed environment. So this poses the big challenge for grid owners. Mm. There are several trends at the same time here, and something that has been happening for a very long time has been digitalization of these big power centers. The grid owners and the power production facilities have been doing digitalization for a very long time, and they started already in the 70s with communication, and long before we had internet, we had substations and power production facilities communicating with each other over telecommunication modems and that kind of setup. And over the years, a lot of investments have been going into that kind of infrastructure to make sure that these centers are communicating with each other as needed, and gradually evolved, becoming more and more advanced, of course. What we now see is that a big part of the electricity grid is being digitized. That is the low voltage grid, medium voltage grid to a certain extent that started earlier, but there is still more that needs to be done. But there has been, let's say, a communication blackout on the secondary level, down below, far below, out to the buildings and houses. The other trend that has been happening at the same time is that at the very end of the customer, we have been introducing meters, by more and more advanced meters. I mean, just doing billing and proper calculation of who is using what has been driving that. So, and meters we have had for a long time. They have been analog. You have to go there and read them and measure, but they have also become more and more digitized. And in some parts of the world, this digitalization has gone very far. I mean, here in the northern part of Europe, we are very, very advanced with that, and are in already the third round of digitized equipment. In other parts of the world, there is no digitalization there. But those enormous amounts of devices and communication streams also needs to be handled. So there are two parts. There is the low voltage grid that have never really seen communication infrastructure that is being digitized. And then you have the handling of all of these meters at the edge. So I would say that the big transformation in the grid regarding communication is in the grid edge. Looking at the challenges the grid faces and all of these changes that are ongoing, one of the solutions that are all over or ubiquitous is the need for communication. Westermo has been for many years targeting the energy sector and has been working with, since long time back, with energy products. And we have, let's say, two major offerings in our portfolio. One is directed at the substation automation, those primary centers, production centers, and equipment that are very robust and resilient, that are intended for these, from an electricity point of view, harsh environments. And then we have a complementary and equally important portfolio that is directed towards the grid edge, where the needs are a bit different than for these big centers, where cellular technology are important, where wireless communication are important. And for the entire sector, we have the importance of cybersecurity as well. Digitalization, introducing massive amount of devices, also introduce a lot of attack vectors for people with ill intent. And this needs to be handled. In the best of worlds, you wouldn't need to care about this, but we don't live in the best of worlds, so we need to handle these things also. Here Westermo has been very thoroughly been working with the cybersecurity aspect of the product development as well.